Okay, in this problem, we want to find the limit as x approaches infinity of the square root of 4x to the fourth plus 7x minus 2x squared. Now, if you try to essentially plug in a really large number for x or plug in infinity to take this limit, you're going to get a form of infinity minus infinity. So that doesn't really help us out too much. So technique that we can try here is the same technique we would try even if this was a number, we were taking the limit as x approached 2 or something, which would be to multiply this by the conjugate over itself, because we do have a radical minus a number. And you might want to think of this as being, it's a little big there, as being over 1, if that helps. So I'm going to multiply this expression by the square root of 4x to the fourth plus 7x plus 2x squared all over itself. Okay, and then we are going to FOIL the numerator because that's the one we've got the conjugate of. The denominator, of course, is just times 1, but even if there was something there, we probably wouldn't want to FOIL it out. So foiling the numerator, we get, let's see, the radical 4x to the fourth plus 7x times itself is going to be 4x to the fourth plus 7x. That's a 4 there. It looks like a 9. There we go. Plus 7x. My outside and my inside terms will cancel. Then my last term is negative 2x squared times positive 2x squared is negative 4x to the fourth. Then down here I've got the square root of 4x to the fourth plus 7x plus 2x squared times 1. Don't need to write that. Okay, we keep simplifying. Then we have 4x to the fourth minus 4x to the fourth on top. And then we have this radical plus 2x squared down here in the denominator. Now what we've got to do is still figure out a way to plug in infinity, because we'd still get infinity over infinity the way we've currently got it written. What we're going to do is factor out some x's here. I'm going to factor out whatever I can out of this denominator. So let's taking a look at this. We've got 2x squared over here. Then right here I've got the square root of 4x to the fourth. And if you're plugging in an infinitely large number, this fourth power is going to be much larger than the 7x. So the 7x one doesn't matter too much, but I am a little bit limited by that in a way. Well, not really. I was going to say because of what I can factor out, but I can force factor out whatever I want. So what I'm going to do is factor out an x squared from both of the radical and this term in the denominator, because I want to get highest power of x's on top and bottom to make this problem doable. So we're going to factor out, actually, you know what we're going to do? We're going to go off to the side and do a little bit of scratch work for this denominator rather than rewrite the entire limit every time. So for just that denominator here, we've got the square root of 4x to the fourth plus 7x. So for that, I'm going to factor out an x to the fourth out of this. So I'm keeping it under the radical right now, though. So I'm left with a 4 in my first term and a plus 7 over, the question is, x to the fourth times 7 over what will give me 7x? And if I put an x cubed there, that will work because x to the fourth times 7 over x cubed, 3 of those x's cancel and I would be left with 7x. Now I'm doing this because we can split up a radical of a product into a product of two radicals. So I can write that as the square root of x to the fourth times the square root of 4 plus 7 over x cubed. And the square root of x to the fourth simplifies. You can write the square root as a power of a half, so you can think of that as x to the 4 halves, or x squared. Okay, so bringing that back over this way, putting it into my limit here, we'll have the limit as x approaches infinity of 7x over. Now in the denominator, I've got this plus 2x squared. So let's go ahead and write it out. We've got x squared times the square root of 4 plus 7 over x cubed plus 2x squared. So we can take an x squared out of both of the terms within the denominator. That leaves me with, let's see, the radical. It's 7 over x cubed there. A little hard to see, but that's okay. And then plus 2. Okay, now one of my x's cancels. That cancels with one of those x's. We'll just write it like that for shorthand here. Now, if we plug in infinity, we basically get 7 over an infinitely large number. If we plug in infinity here, okay, the numerator is a constant. 7 over x cubed would be 7 over infinity cubed. That little fraction right there would approach 0. That x is going to approach infinity, so this thing would approach 7 over some kind of infinitely large number times a constant square root of 4 plus 2. Well, 7 over an infinitely large number is going to approach 0. So that's what we get for this limit. The technique was to multiply by the conjugate over itself and then factor out what we could from the radical.